I am Mariana Costa Lima. I have a master's degree in Architecture, Urbanism, and Design by UFC, the Federal University of Ceará, in Brazil. Currently, I am an associate researcher at the same university.
Hello, I'm Eugênio Moreira. I have a master's degree in Architecture, Urbanism, and Design by UFC, the Federal University of Ceará. Currently, I'm an assistant professor there.
Hi there, I am Sara Farias. I have a bachelor degree in Architecture and Urbanism by UFC, the Federal University of Ceará. Currently, I am an associate researcher at UFC.
Hello everyone, I'm Clarissa Freitas. I have a PhD in Architecture and Urbanism at the University of Brasilia. Currently, I'm an associate professor at UFC. We are here to share with you some results of the research that we have carried out with the use of computational tools in urban planning, especially in areas of informal settlements, managing and producing data about its urban form.
Well, we are Brazilian researchers and, as in the vast majority of countries of the Global South, official data about the built environment are scarce, outdated, or simply non-existent, especially in informal settlements. Existing computational tools, mostly produced by countries and researchers of the Global North, are not prepared to deal with the degree of heterogeneity in our urban areas. What we propose here is a method based on computational tools to structure, analyze, and produce georeferenced data, aiming to support participatory planning processes in informal settlements. The results include mapping basic elements of urban form and also automatic extraction of some urban parameters. The method proved relevant to allow not only the collaboration between team members, but also the dialogue with the community members, revealing its role in fostering a transformative design process.
We live in Fortaleza, a coastal metropolis in northeast Brazil. We use Fortaleza's spatial pattern to reflect on the promises of the manipulation and production of urban morphology data. Mostly, we seek to understand how the paradigm of information modeling can assist the decision-making process in urban planning, both on formal and informal urban tissues. In 2019, due to our previously developed expertise, we have been commissioned by a local planning agency to compose a multidisciplinary team that would propose special regulations for 3 informal settlements in Fortaleza. These settlements have very different sizes and locations within the city. While Poço da Draga is a small coastal community encroached by recent tourism developments, Bom Jardim is a peripheral neighborhood comprised by several smaller occupations. NPC is a working-class community located near the main university campus. Together, we estimate around 14,000 plots, 85% of which were not represented on official municipal maps.
In order to face the task of developing special regulation for them, we needed to consider the existing built environment. So, we relied mainly on 2 previous research experiences. The first developed a digital framework for representing the city as an integrated set of computational applications communicating with a single database, something that could be called a city information model. The backbone of the framework is a relational database management system, which is used to structure the database in a remote server, accessible through the establishment of a virtual private network. This type of platform allows the management of different access levels for the different stakeholders in the planning process, the storage and manipulation of geometry and attribute information simultaneously to import a wide range of data formats, and the storage of a very large quantities of information. Also, it makes possible the connection with different tools for analysis and visualization, such as web applications, statistical modelers, and geographical information systems, the last one heavily used on our research. The greatest innovation of this platform, however, was its possibility of connecting to an algorithmic modeler, allowing the use of a visual programming interface associated with a CAD software, allowing the composition and the operationalization of algorithms for analysis that produce relevant data for the context in which we work.
The second relevant research experience has produced urban analysis algorithms using the framework previously described. The algorithms were based on minimum urban standards of livability and accessibility criteria for urban services set by Brazilian scholars such as Ricardo Moretti and Laura Bueno. It was also based on Berghausen and Haupt's space matrix urban density framework. Building upon these 2 sets of urban parameters research trends, we created modules for the analysis and production of data about the built environment of informal settlements in Fortaleza, Brazil.
With this experience, we faced the task at hand. The first challenge was the lack of data about the areas assigned to us. To compose our initial database, we had access to official data provided by the local government. The set was composed by suborbital images captured in 2010 and 2016 with a spatial resolution of 0.10 meters. Vector data sets consistent with the image's time span, including the representation of basic elements of urban morphology, straight X-lines, islands, lots and buildings footprints, vector datasets with the location of public facilities. Although the images had good spatial resolution and the location of public facilities was reasonably up to date, there were significant gaps in the mapping of the basic elements of urban morphology. Straight X-lines and building footprints were quite consistent, but the lot layer has about only 15% of the actual land parceling. One of the possible approaches was the use of automated data extraction from the imagery set. To provide one, even with a good spatial resolution, doesn't have a good spectral resolution, which can decrease the accuracy of the classification. Due to our lack of resources to access high-resolution orbital images, we used the capability of collaboration provided by the Relational Database Management System to manually vectorize the lot parcels, dividing the area into sectors and assign each sector to a member of the research team. I worked simultaneously on using a geographic information system for the production of geometric data, and all sectors were previously joined with SQL, which allows the final result of the update to be tracked in real time by anyone with access to the database.
Once all the vector layers are updated, it became possible to retrieve its data on the algorithmic modeler, feeding the analytical algorithm for the extraction of urban measures. Although we had algorithms to produce some data about the streets, we have been commissioned to evaluate current housing conditions on the individual dwellings. So, every measure about the streets should be projectable in the lots, working as an indicator. Most of the available tools do this by plotting the centroid of the parcels and projecting it to the closest street axis. Although this technique could work in most of the cases in the former tissue of global north cities, it often fails when applied to the irregular, heterogeneous informal urban fabrics analyzed. Narrow plots are quite common, which has their centroids closer to a lateral street than the one that serves as their axis. To deal with this, we proposed a process that starts by exploding the lot polygon on its constituent segments, then creating vectors perpendicular to each segment, passing through its midpoint and projecting that point in both directions of the vectors. The projected points are tested against all surrounding lot polygons. If any of them is not within the lot, the associated segment is considered a free face. Using only these segments, their midpoints are projected against the street axis, allowing the creation of one or more points that represents the lot tied to its axis streets. The algorithm measures the length of these lines and incorporates it to the lot data. Since this calculation must be done for a massive set of entities, the process was automated through a loop, making it possible to deal with each entity in sequence, accumulating the results obtained in an ordered list. Finally, the points on the street network are used to calculate the distance of each lot to a set of amenities, such as bus stops, schools, hospitals, and so on, using the street network. Since the available tools operates with the network topology, the path calculated between the points only computes entire segments, discarding the stretches of the street segment in which the points are inserted and that need to be traveled until the nearest intersection is reached. So, the team created an algorithm structured to incorporate those stretches, making the measures more precise. As previously described, a loop was used to cycle through all the entities and accumulate their metrics in an ordered list. Some benchmarks found in the literature were used to evaluate the accessibility of the lots to the surrounding amenities.
The output data was the fundamental element to inform the design charrette undertaken with a group of residents of each of the three settlements. Some of these charrettes aimed at defining the threshold of urban indicators that would legally establish the minimum housing conditions. In order to achieve this informed dialogue, it was necessary to make a translation between technical and community language, going from digital to analogical tools. The team used, for example, maps printed in transparent paper to show how many lots have indicators below a certain parameter value to support residents' decision on the minimum parameters to be adopted by special regulation.
A gente tem 3% dos lotes que estão dentro do PCI. seja, todos esses pinguinhos aqui são lotes diferentes. Ó, chega a gente ver que eles são bem mais estreitinhos, né? E tem essa testada de 3 metros. Aí, se a gente usar esse número de 3, esse pessoal aqui, esses 3%, eles vão ter que receber alguma melhoria, vão ter que passar por alguma adequação para estarem dentro da lei nova, né?
Esses aqui são menores que 3 metros.
Isso.
Todos eles têm a testada na frente menor do que 3 metros.
By using a wide range of digital and analogical tools, the proposed methodology was able to meet the 2 goals initially set in order to foster a collaborative and participatory design process. It not only contributed to current literature on city information modeling, but also delivered a relatively accessible method to support bottom-up decision-making about urban regulations, more suitable to the distinguishing realities of cities of the Global South.
And that's it. If you're interested in discuss something about our work, please email us. Thanks for your attention.